Hello, friends. As we all know, it took 2.9 billion years for life to evolve from unicellular to multicellular organisms. But what if I told you that scientists at Michigan State University have replicated this exact evolution in just 600 days through an experiment? According to me, this is the most groundbreaking experiment ever conducted on Earth. Finally, this experiment might answer evolution's biggest mystery, a mystery scientists have been trying to solve since 1988. How do we evolve from unicellular organisms like amoebas into complex multicellular beings like humans? The one-word answer is oxygen. Listen closely. This is fascinating. In 1988, biologist Richard Lenski from Michigan State University decided to study the evolution of unicellular to multicellular organisms in detail. For this study, he chose E. coli bacteria because they double their population in just 4 minutes. He started by growing 12 different E. coli populations under identical conditions and food supply. Over time, these bacteria evolved through 74,500 generations, equivalent to 1.5 million years of human evolution. Lenski observed that each new generation grew 70% faster than the previous one. Half the population even developed DNA repair abilities. After 20,000 generations, the bacteria eliminated and used metabolic functions, producing only the enzymes needed to process their food. This mirrors how monkeys evolved necessary traits for survival, eventually leading to humans. However, bacteria never form multicellular structures. So, in 2010, evolutionary biologist William Radcliffe repeated the experiment using yeast, a eukaryotic organism, instead. Yeast can double its population in 90 minutes and has 20% genetic similarity to humans. Radcliffe grew yeast in a nutrient-rich medium at 30 degrees Celsius. After 60 days, the yeast formed snowflake-like structures with genetically identical cells, a primitive multicellular organism, but growth stalled at 100 cells. To mimic earlier low-oxygen conditions, researcher Ozan Bozdag placed these structures in an oxygen-free environment. Shockingly, they grew into clusters of 450,000 cells visible to the naked eye within 600 days. Under oxygen-free conditions, yeast cells develop thicker, wood-like cell walls at branching points 100x stronger than normal. Scientists concluded that harsh early Earth conditions, like low oxygen, likely drove unicellular organisms to evolve multicellularity for survival. Another clue came from bacterial biofilms, slimy layers protecting bacteria from antibiotics and immune systems. Discovered in 1970, biofilms cause 70% of bacterial infections, killing 7.7 million annually. Scientists believe biofilms represent a transitional link between unicellular and multicellular life. But how did the first cells form? In 2023, chemist Lee Cronin created inorganic chemical cells, ICHLs, by mixing positively charged aromatic molecules and negatively charged metal oxides. These form membranes allowing ion flow, mimicking primitive cell functions. Cronin suggests such structures evolved into prokaryotic cells, then eukaryotic cells with organelles. In summary, these experiments decode life's journey. 1. Inorganic molecules, primitive cells. 2. Unicellular organisms, multicellular life driven by oxygen scarcity. 3. Biofilms, complex organisms. While evolution explains life's diversity, it also creates dangerous pathogens. Recently, a deadly fungus turning humans into zombies has emerged globally. Check my video on this topic for details. If you enjoyed this, smash the like button, follow the channel, and stay curious.